Welcome to The Explainer. Today, we're diving into how physicist Brian Cox sees the universe, tackling some of the absolute biggest questions about the cosmos and, well, our place in it.
Why are we here? I mean, it's pretty much the biggest question there is, right? Now, science can't just hand you a neat and tidy answer, but what Brian Cox argues is that it gives us the essential tools, the framework, to even start looking for one. Okay, so what he's saying here is pretty clear. Scientists aren't going to give you the meaning of life, but they can give you the essential background info you absolutely need if you're going to tackle that question for yourself. So what are those things we need to know? Let's get into it. All right, first things first. We have to wrap our heads around something that is, well, almost impossible to wrap our heads around. And that's the sheer mind-blowing scale of, well, everything. So Brian Cox kicks things off with this number, 2 trillion. And get this, that's not 2 trillion stars. Nope. That's 2 trillion galaxies. I mean, each one of those has billions of its own stars. It's a number so big, our brains just can't really process it. And okay, let's just zoom in from that insane cosmic scale to our own backyard, the Milky Way. Even here, the numbers are just staggering. We're talking about maybe 20 billion planets that could be something like Earth, just in our galaxy alone. And you know what? That feeling, that sense of your brain just going numb, like Joe Rogan says here, that's totally normal. Even the scientists who study this stuff can't really picture it. But here's the key takeaway from Cox. Just accepting that unbelievable, mind-bending vastness, that's the first step. That's the foundation of the whole framework. Okay, so we've got the scale down. Kind of. The next piece of the puzzle is the origin story. Where did all this stuff come from? And this leads us to one of the absolute biggest questions in all of cosmology. So here's what we know for sure. If you rewind the clock about 13.8 billion years, the entire universe we can see was squeezed into this tiny, incredibly hot, dense point. And that moment, that's what we call the Big Bang. But here's the real head-scratcher. Was the Big Bang the actual beginning, like the absolute start of time and space itself? Or is it possible the universe has just always been here, maybe in some kind of endless cycle? Well, one of the wildest and most popular ideas out there is something called eternal inflation, and it paints this incredible picture. It suggests that our entire universe, everything we know, is just one little bubble that formed in a much, much bigger cosmic ocean, a multiverse that is still expanding, eternally. And this whole multiverse idea, it actually helps explain something kind of weird. The chunk of the universe we can see looks perfectly flat. Now, think about it. If you're standing in a field, the Earth looks flat, right? But we know it's a giant, curved sphere. The multiverse theory suggests the same thing might be happening on a cosmic scale. We're on such a tiny piece of a much larger, possibly curved reality that our little patch just looks flat to us. All right, so we've got a sense of the scale and where it might have come from. Now let's look at the rules of the game, the processes that run this place. Because from the biggest stars down to the tiniest little microbes, the universe is just this constant, incredible cycle of life and death. I mean, just look at stars. Their whole life is this epic battle, right? You've got the explosive force of fusion pushing out and the massive pull of gravity crushing in. Eventually, they run out of fuel, gravity wins, and bam, they collapse. And for the really, really massive ones, their story ends as a black hole. So what makes a black hole a black hole? It's this boundary called the event horizon. You can think of it like the point of no return on a waterfall. The moment you cross it, space and time itself get so twisted and warped that every possible future path you could take leads to only one place, the singularity at the center. There's no escaping. Okay, so you've got all this cosmic drama, and you've got those trillions of galaxies and billions of Earth-like planets we talked about. Put it all together, and you get one of the most famous questions out there, the Fermi paradox. If the universe is so vast and so old, where is everybody? Well, to even start to answer that, we have to look at the only example of life we know, us. And our own story is weird. Life got started on Earth pretty fast, geologically speaking. But here's the kicker, and you can see it on this timeline. For more than 3 billion years, life on Earth was basically just slime. Simple, single-celled organisms, that's it. So that huge jump from simple slime to complex creatures like us, it might not have been guaranteed at all.
In fact, it could have been a total fluke, a 1 in a trillion accident. The idea is that maybe one single time, in what's called a fateful encounter, one simple cell swallowed another, and instead of dying, they learned to live together. An accident that took billions of years to happen. And that idea, the idea that we might be the result of an unbelievable cosmic accident, well, it completely changes how we think about ourselves. It forces you to reconsider what it even means to be human. You see, Brian Cox makes a really strong argument that we could be the only thinking, tool-using civilization in our entire galaxy right now. I mean, think about all the things that had to go right. We needed 4 billion years of stability. We needed a solar system with a giant planet like Jupiter acting as a cosmic bodyguard, sucking up asteroids. And we needed that incredibly rare accident that created complex life in the first place. On top of that, who's to say civilizations even last very long? And this is where we get to the absolute heart of Brian Cox's whole framework. If we really are this rare, if we're alone in our galaxy, then meaning isn't some grand, universal truth that's just floating out there in the cosmos waiting to be discovered. No, it's something we make. It's a local, temporary thing that emerges from us, from these complex arrangements of atoms. It's created right here by us. Look, this viewpoint doesn't offer any simple, cozy answers. It's not supposed to. But as the legendary physicist Richard Feynman pointed out, the most important thing science gives us is the knowledge that we don't know. And there's a kind of incredible freedom in that, in admitting that we don't have all the answers. I mean, at the end of the day, it's not just a poetic idea. It's a literal fact. The very atoms that make up your body, the carbon, the oxygen, they were forged in the hearts of stars that died billions of years ago. We are literally made of stardust. And so this is the final, profound idea that Brian Cox's whole perspective builds towards. We aren't just living in the universe. We are the universe. We are these temporary, fragile structures built from star stuff that have, against all odds, evolved the ability to think and to feel and to wonder. We are the universe's way of knowing itself. And really, what more could you possibly ask for? So that leaves us with one last big question to chew on. If we are this tiny, temporary island of meaning in a silent sea of 2 trillion galaxies, what does that mean for us? How should we act? What's our responsibility?